Welcome to my channel. In this video, we will talk about how to train a model after you have the data prepared for machine learning. Okay, let's open our project folder with Visual Studio Code and create a new file. Name it ml004 trained model.py. So we have gone through the data loading, preprocessing, and splitting data. So now we can do the model training. Then we will demonstrate how to persist the model for future use. Okay, let's type in from sklearn.datasets import raw iris. We will also use NumPy, therefore type in import NumPy as MP. Now create a variable called dt to hold the data. dt equal to load iris, this function. Our feature matrix x, capital X equal to dt.data, and the response vector, the independent variable y, little y equal to dt.target. Let's also get the feature names. Feature names equal to dt.featurenames. Let's print out the shape of x, y, and the first 5 rows, and maybe the feature names, and take a look. So we have 150 records, and the feature matrix have 4 columns, and the 4 features are sepal length and width and petal length and width of the iris flower. We can tell that data is not standardized. Let's comment out this block of code because we don't need to see the data feature again. Then we will demonstrate how to use the preprocessing functions to check the data. Let's type in from sklearn.preprocessing import standard scalar, and let filter equal to standard scalar parenthesis dot fit parenthesis x. Let's use NumPy to calculate the means of each feature columns in a for loop. Then we will compare them with the means calculated from standard scalar. So let's put a label here, say means calculated manually, to distinguish it from the mean calculated from standard scalar. And the means are available in the filter.mean underscore. We can also print out the variance. It's filter.var underscore. Let's adjust the printout and display a little bit here. And we can see that the mean calculated from either methods are the same. And they better be the same, otherwise we will be in a big trouble. Okay, let's comment out this section of code because we don't need them for our model training. We will only keep line 1920, the import standard scalar, and the filter variable for later use. Since the original data is not standardized, so let's standardize the data and compare the model fitting between standardized data and the non-standardized data. So let's use the standard scalar parenthesis dot fit transform parenthesis x, then assign the standardized data into capital S. Print out the first 5 rows of the standardized data. We can see a lot of negative numbers show up in our data set. Let's recycle our previous code and use the NumPy to calculate the means of the standardized data. Okay, run the code and we can see that the means are almost 0. Let's comment out these 3 lines of code here. Now we are going to split the data into training and testing data sets. So from sklearn.model selection import train, test, split. Create 4 variables xtrain, xtest, ytrain, ytest equal to train test split parenthesis. We will split the data set x and y with test size equal to 0.3 and random state equal to 1. Let's print out the X train, Y train, X test, Y test, and maybe just their shape and take a look. There are 105 records in the training dataset and 45 records in the test dataset. Remember that we have a standardized dataset, and we can split the standardized dataset altogether in the train test split function. So let's add the standardized dataset capital S into the splitting function with capital S train and capital S test as the variable to receive the data. Let's also print out the S train and S test, their shape, for review. So far so good. Let's comment out these 6 lines of code for now because we are going to do a model fitting, and we will fit a k nearest neighbors classifier model. Let's type from sklearn.neighbors import k neighbors classifier. Also from sklearn import matrix. Here we will train 2 models. One use the original dataset and the other will use the standardized dataset. Therefore, we will create X, capital X, model KNN equal to K neighbors classifier, parentheses, N neighbor equal to 3. KNN classifier is based on the majority votes. So here we just use 3 votes to decide a data point's class label. Now we can fit our model by doing X model KNN dot fit, parentheses, X train, comma, Y train. Now we can copy line 54 and 55 and paste below and modify it for using the standardized dataset. So we'll change to use S model KNN. And the input data set will be capital S train and the Y train. By the way, we usually don't standardize the Y variable because we only have one independent variable. Therefore, there is no measurement unit and scale differences that need to be standardized. Let's enter Y predict from capital X equal to capital X model KNN dot predict, parentheses, X test. So we have a prediction from this training section, and using the X test from the original data set, we can print out the accuracy rate to evaluate the model's performance. The matrix.accuracy score function can provide a calculation. We simply feed in the Y predict from model X and compare with its original value, which is Y test. Likewise, we can do a prediction from the standardized dataset and then print out the accuracy score of this model based on a standardized dataset. We can see that both models provide the same accuracy score. Let's print out the predictive values of Y compared with its original values. Okay, now run the program and print it out and compare. By the way, the use of the standardized data being not affecting the accuracy score, it is probably because all of the 4 feature variables are measured in same scale and unit. which is in centimeter. Here we spotted one prediction error. It is one error out of the 45 data point prediction, so the accuracy is 97.7%. It's very high. Let's comment out the code that print the accuracy rate, and we will talk about how to persist the model, save the model for future use. Once the model is trained and the accuracy score is satisfactory, then we can persist the model using the job_lib. Therefore, let's import job_lib. Then type in job_lib.dump. Then give it the model that we want to persist and the file name to save to. Now run the program and we will see that the iris classifier knn.joblib file is saved to our project folder. Okay, that's it. That was the model training and the model persistence. In the following, we will adjust the number of the nearest neighbor and the random state to see how they affect the accuracy score. The documentation suggests that we should use odd number when setting the n neighbors parameter, which can prevent the equal votes when selecting the class label. Okay, so we just randomly change some of the parameters and see how the accuracy score being changed. Okay, that was the model training and the persistence. If you like this video, please thumb up and subscribe. Thank you.